Hello, everyone.
Okay. Hi, everyone. Welcome to our session. This is Shalo Arshi, and I am with Women in Big Data, one of the co-founder, and that we started, the organization in 2015, and in 2020 we turned it into a nonprofit, so we can have our funding to really, bring some programs that we think it's very valuable to our community. The same founders that started it pretty much continue with it, and we are very happy to really, providing opportunities and programs such as mentoring program, which is our flagship, and it runs every quarter with really rich sort of a program. We have a lot of events, networking and such, which really, every chapter really runs them in their own local. And we have leadership training for, many of more internal leadership. We have over 100 core team members that we really try to also, support them to get to the different levels, providing them opportunity within the organization. And of course, we have training, as you see, this partnership with data camps is also, part of our training. We do have other program, podcast, and hackathon program, fairly new, both of them, and over a year or so. And they are, running really, nice sort of, programs. We do have our website that, you can try it and find, a lot more, sort of details on who we are, what we do. And we really, have our members through multiple different channels. And one of the channels is through our membership on our website. But of course, we do have a LinkedIn group and our company's, page on LinkedIn, which has, its own members. And we try to see as much as possible to consolidate so we can really communicate with them more effectively. Can we go to the next slide? I want to wrap it up so we can get to our exciting talk today. So as I mentioned, this is really our one of our objectives for the training, to provide something meaningful to the community. And we have been very lucky to have this partnership with DataCamp Donates that provide us with pretty much unlimited licenses. Every year we have to apply for it, and we are very grateful that we have this opportunity through this year, and then we're going to apply again next year. And it's all based on the performance of our learners, how they are performing, how they are using it. So the stronger performer we have and really utilizing the platform, the better opportunity for us to continue bringing this to everyone. So we are very excited with this relationship with DataCamp. They have been amazing partners in every aspect. And DataCamp, they have over 400 different data-related courses that they offer. But the best part of it that we always wanted to really bring to our community is the certification program they have. They have multiple tracks, and based on those tracks, you can just pick what you like to do, and then they offer certification. You have associate and professional certification, data analysis, the same associate and professional in the data science. They also have, certification in data engineering. So it's really very rich program. You can just, as we have the link here, you can explore more opportunity if you are new to this data camp. If you're already taking, the classes, thank you so much. And we're really, grateful for you to utilizing such a great, platform. So continue learning. Oh my God, this is our first, learner that has achieved a certification program. We actually start offering, the data camp. I think it was mid-December, so it's really fairly new, 4 months into it or so, 4 or 5 months. And Khadija is detailing, what she has done. She got her associate data scientist in Python certificate. And as you see how much effort she has put in it, I believe she did it in a month. Shabasti, is that true?
Yeah, joined in March. And yeah.
My God, my God. Commanding. So it is possible if you have the time and you can really spend. She did 86 hours of learning, 22 courses, 11 projects, and skill assessment, and she got really top, sort of a percentage, which is incredible. So she is very dedicated. So we are proud of what she has done, and we would like to get more of you to really encourage you to take this serious, because this would help you. This really, there is nothing here that you don't benefit from it if you spend the time to get your really, the certificate that they offer through this program. And it's really at no cost to you. And you have the license, you can take this certificate, even if you fail, you can continue taking it over and over and over again. Every time you learn something, and eventually, of course, you have to take your courses and you have to do your assignment to get there, to be able to take the certificate. But even if you fail first few times, continue, just sharpening your skills and just taking it again, and you will pass. So no magic to it. It's just hard work. But you are all, yes, go ahead, Shabasti.
Yeah, that's so true, Shala, because eventually that's what it is, right? Like I've taken other paid certifications, right? For them, you have to pay each time you try. But for data camp, we can try, n number of times for free, right? We're not getting charged. So really, there's no harm in just taking the test, get a feel of it, the pattern of questions, and then go ahead and, go for the main exam as many times you want, right? So.
And we just in discussion with data camp. So one of their teachers, and she is coming we're gonna have a meeting arranged with her. So she would just focus on certification, not just how you take the certification, but really, focusing on the value of it, because data camp also provides some community to those that they are, certified, give them really, more to work with, and they connect them with companies and others. I believe that's what, when I was looking into it and taking some of their courses, when we started, our engagement with them, we had to go through training, and they really, talk about that community that had certification from data camp and how much they really provide opportunity to them. So we will have that session. I think, Shabasi, you're going to come up with the date and time that hopefully would help everyone. That would be a very valuable discussion. Okay, I'm going to pass it to you, I think, Shabasi.
Yeah, of course. Out for our top learners for the last 30 days. This is always for the last 30 days who's earned the most. So Khadija, Yanmin, Anna, Lan, Karpagam, Modupe, Natalia, Alia, Audrey, and Isabel are on the top 10 learners. And the rest of you who are learning, hats off to you for continuing to learn, and you would be one time at the top as well. And really encourage all of you to go for the certification for whatever courses you're doing. Just highlight on any key simple path that you want to follow, whether it be analyst or engineer or scientist, and then go ahead and just go for the certification after you do the courses. And now we really want to hear from you about your learning journey as you're completing the courses, taking the certifications, what you feel about it. We really want to hear from you, your testimonials. Please do talk about it on social media and on LinkedIn. And if you don't want to do LinkedIn, you can just send us a note as well. That also works. So that's just a little bit that you can do. And now over to Sridevi. Very thankful to Sridevi, who's agreed to be our guest speaker for today for AI for utility. She would be talking about it. So I wanted to tell you, she has a lot other than what is here on the slide, but I'll just mention it. She's a PhD in mathematics, and she's working as an associate teaching professor at Kansas State University. She teaches machine learning, deep learning, and Python. I've been a student of her Python class, starting when she was teaching in UCSC Santa Clara Extension. That's from there we met, and now she's been a part of Women in Big Data. She's helped us for the Data Science Olympiad program. She's been a mentor for that. She's led her team, Square Roots, for completing, getting the whole team started on the data science journey. She's also co-authored 2 books, Image Processing and Acquisition Using Python and Essential Python. Feel free to connect with her on LinkedIn. We would be sharing the slides and the details. And over to you, Sridevi. Thank you so much.
Thank you, Shrabasti. So thanks everyone for joining. It's nice to have you on a Friday. I don't know, hopefully you're all on this Friday, time, not on Saturday. It doesn't really matter. I guess everybody's welcome. Just everybody. So, I'm from India, country India, and so we value gurus like the teachers. So Shrabasti is, my student who is very loyal. She invites me for many things, and she gave me an invitation for this. And I was part of the mentor group in spring for Women in Big Data. So let me just start, so she's a good student to have, I guess. Who's always looking after her educators. Okay, so I just wanted to start off with this image. So this kid and this kid are Srabasti's girls, daughters, and this daughter is my daughter. So they take good care of my daughter. So I just wanted to say that they make my Zuzu special, feel special. Okay, so coming to the top, I hope you guys can see the screen, my PowerPoint presentation. I don't like to go into because I want to know what slides I'm looking at. So let me see if I did it. Okay, maybe this is okay. So hold on.
Yeah, we did see you when you were presenting slides. All good.
Okay.
All good. Thank you so much.
Thanks. Yeah. So I just want to, so this talk, I want to talk about what we do at Kansas State University, not only in the machine learning program, but just give you an overview so that, if you want to take classes or, you have kids who are ready to go and take classes or, you have relatives, friends. And then I'll talk about the problem that not only my department, but I'm working in coherent with another department within the Kansas State University, and we are working with an outside partner. And how did we acquire data and what did we do? It's still work in progress. So this is happening in this this semester. So we didn't completely finish the project. So we are coming to the end of it. So I'll talk a little bit about the deep learning model. Okay. Sorry. Okay. So this is a very unique campus that we have at Kansas State, Salina. So this MLA, you might be wondering whether I'm in Salina, where am I located? I live in California. So the program that I'm in charge of, it is, sorry. I don't know, I'm admitting students are waiting because, of the attendees. And so the slides are changing. Okay, so, okay, so this is a very, so the program is an online program. So that's why I am working from California, but the campus is in Salina. And it is a unique because it's an aerospace campus. So we offer, we train pilots. So they can get degree in bachelor's or associate degrees. And we also have aircraft maintenance degrees. So mechanical and electrical engineering, same, bachelor's or associate degrees. We have 1 mile airstrip. So, it's very unique that, we have that. And the next thing is, of course, I'll say my program is great, which is machine learning, but it is, it's machine learning and autonomous systems. So we're not just doing machine learning, we are also trying to, cover the autonomous part. We have come up with a new program called Cyber Systems Degree and Design and Degree. So in that, one of the examples is, we'll be training students on creating games. Okay, so the games are, just computer games, or they could be AR, VR games. So we have AR, VR lab, we have Oculus and HoloLens and all. Okay. So the other thing that, Kansas State University is unique, I have worked at different places, different educational institutions. So what I can say is that we have a lot of partnerships. So the project that I'm going to talk about today is also, is a partnership with an industry, right? So I think the unique thing is students can get opportunities to work with, a lot of different companies. And also specific companies, if they want to just work on specific things, like General Atomics is one of the good big donors, and a lot of departments work with General Atomics. 1 second. Okay. Pure Imagination, Pure Imagination is a company that's located in LA. They have partnering with us, and we are going to build a big, simulation lab, because you can think about it, right? Like, we have flights, and, we are training pilots. So there is, simulation is one of the important things. So it's very natural that this huge company, which is producing games and all that for virtual reality, is interested in partnering with us. And one second, one more guest. So Garmin is another company. We have a lot of partnership with Great Plains Manufacturing. Okay, so we get a lot of scholarships and internships from them. Okay, so coming to my program, which is about machine learning and autonomous systems. So this actually autonomous systems, when I was getting interviewed, I looked up, how many universities are offering this. There are not that many universities in US which are offering at any level. Okay, there are some universities in the UK, and that's about it. And you can see that there is so much demand. So when we look at autonomous, we just tend to see that, oh, the cars. I can see that cars is the, I think, direct application. We can see that, hey, yeah, a lot of, we hear about a lot of companies investing in autonomous vehicles, but there are, autonomous vehicles that, consumers use, but there are also autonomous vehicles that we don't directly use, but they are used within the industry, like John Deere is coming up with a lot of autonomous systems for, tractors. There are other companies that are coming up with, maybe, they're drones, so the drones are autonomous, but they are used to pick fruit. Okay. And some are, weed killers. So they just go and, instead of putting fertilizers or weed killers or something like that, these machines will go and identify which are the weeds, and then I think they're using electricity to kill the weeds. Not 100% sure of that part, but so the autonomous is something that we are seeing that is coming to us, like, self-driving cars or taxis. But there are a lot of autonomous things that are happening, in other parts and other industries. So we are actually we are offering 3 things. One is a bachelor's, and another one is master's. But there is also a certificate program, master's certificate program, that somebody can get. Okay. Okay. This particular product, the partnership. So I'm not going to divulge the the partner because I don't know. I didn't, I mean, I don't feel comfortable doing it. So the partner is in utilities, and so the thing is, if you look at woodpecker poles, so there are a lot of damages that can happen, right? I mean, to an electric pole, and the electric poles are, some are metals, but not every one of them is a metal. Sorry, one second. Yeah, so Not all poles are metal poles, they're very expensive. So as of now, I think around 90% are wooden poles. Okay. So the industry partner, I think they already partnered with my colleagues in different departments. So their thing was, hey, we collect information, we collect, pictures of the poles, and we want to identify the pole has a hole, woodpecker hole. Okay. And so that is how I got introduced to the partner, and I'm like, okay, this is great opportunity. Usually we don't get the, we are not somebody who gets the data. It's mostly like we are using the data. So somebody already got the data, they curated it, we are at the other end where we are using the data. So this is a great opportunity where we are in touch with the partner. We can get the data and try to understand, what they want and what we want, to do a good job. So, so this partnership with the industry partner, but within our campus, my department, which is MLAS, is partnering with unmanned aerial systems. Okay, you just call them UAS. Okay, so it is unmanned in the sense that nobody's, is pilot, there is nobody inside the machine, but somebody has to, direct the machine, right? So, so we are using drones, so nobody is inside the drone, but we still have to guide the drone to all that. So it's still, there is a man thing, but not on the, so it's kind of a little bit confusing, but there is a human involvement is there. All right. Okay, so utilities of power companies, majority is production, but even if you think about it, the distribution is also very important, right? Because you cannot store energy. Okay, capacitors are there, batteries are there, but they cannot hold a lot of power, right? So that there is a limited power use. So as the power gets generated, we want to use it. Okay. So that's why there is a lot of, analytics about how is the usage like, what are the peak hours. And if you notice the peak hours, charge per use is different, okay? So when it comes to distribution, there is an energy loss just because, anything that has to pass through a certain amount of distance is going to lose energy, regardless of what, is it through electric poles or some other means. So one of the important factors in distribution is, after transformers and all that, is poles, right? So there is a mandate, at least in California, that the state is expecting the utility companies to have power lines underneath, because we have been having wildfires, and because of that we are having blackouts and all that. So but that is work in progress. So not all electric power lines are above, under the ground. Okay, so there are still poles, and there are wires above the ground. So typically the problems that poles face are damage due to weather, storms, and lightning, because just lightning hits something which is taller, more probability of it hitting. So the other one is woodpecker damage. And woodpecker, also the wires themselves could have some problems, but woodpecker damage, industry-wide, it is around 5 to 10%, cost-wise, for maintenance, for replacement. So, and as we know, anything that needs specialized either workers or, equipment, it's going to be expensive, right? So the other few more historical things are that, before it was not like, there was a lot of research done to, put the poles, or, consider which wooden poles are better and all that, right? Which wood is good. So mostly some of them were treated, but how much can you treat them before you use them, right? So you can see that this pattern of improving the quality is always happening, right? In terms of for cars, for houses, for electric circuits and all that. So even for poles, while there is, the damages look like this. The woodpecker damages, so the woodpecker pecks on the wood to get larvae, or it could be, to nest, to, store something, So there is, especially woodpeckers, female woodpeckers are the mostly, ones who peck. Okay, peck the wood. So as long as the hole is not that wide, so we talk in terms of the diameter of the hole. So while small holes can cause problems, they still capture moisture and all that. But the ones that are concerning are something that are of 2 diameter or more. Okay. And these can, mostly it's not like the woodpecker is, coming and only, so the woodpecker is not coming only and, saying that, okay, I'm not going to, it's not going to be choosing, right? I mean, it's not going to be considerate towards, okay, I'm going to make a hole where it's very easy for some maintenance person to, cover it up or paint it over or, do a wood filler. So the woodpecker can do it anywhere, and it looks like, some wood there, is more prone to getting pecked by a woodpecker than others. Okay. Lately, what they have been doing is they are treating these wood before they, put it as poles. So it seems that if the depth has to be at least 4 inches for it to be treated. Okay. And if they, if it is treated, then woodpecker would not be, it won't be enticing for a woodpecker to, make holes. Okay. Okay, so as I said, so we had the luxury of working and getting the images instead of saying that, hey, you collect the image, I will do the data process, right? So our team, one team is called a flight team, which who have partner, the drones and the camera, everything is provided by the company. And the company has, of course, somebody who can accompany our students because, we can't just fly a drone, right? I mean, the people, the neighborhood, they might be objecting. So the company has, it has license. It has license to collect data. Okay, so it has permission from the government, from those counties or cities or neighborhoods to collect the data. So our, the flight team are the students who know how to fly the drones. Okay. So there are 2 parts to it. So the drone doesn't have any way to capture the images, okay? So the drone is there, and then we have to attach a camera to the drone, okay? So the total cost is around $35,000. The drone is like $15,000, and the camera itself is $20,000, I think, around that range. So there are a lot of challenges to collect images. One is, the weather is the bigger one. So it could be too cold. It could be windy, right? The terrain. So there is flat land, and of course there is, mountainous and all that. So maybe, there is a stretch of water, that is also in between the poles. So it is not very easy to capture images, and also for the same reason, it's not easy to maintain them, right? Somebody cannot go, because of the height and all that. There should be some safety equipment. So, for a human being to just go and check it out every time is a difficult thing, right? So that's the reason behind, seeing if there is any kind of, is there any deep learning or any other technique can be used to provide, what is happening with the poles, like, do they need any maintenance? So it is like, we are always trying to understand, we are capturing images and seeing, what is the wear and tear of the pole? Do they need replacement? Or, what kind of maintenance will they need, right? So that is constantly happening. Sorry about that. Then I 10 minutes of it. Okay. So that is a flight team. So the data team's job is, so it's not like the flight, we didn't talk to the flight team. So we had weekly discussions. So the interesting part about this company was they allocated a scrum master. So, there was an agile I was new to it. I never worked in industry, so this was a good learning thing. So the students, including both the flight team and the data team, they all were given talks on how to write reports. How do you do? We had a leader, okay, a team leader. So the question was, how do you communicate, right? I mean, how do you collaborate across different departments, and what are the, how do you set up your expectations? So there were weekly meetings, and I was also involved because it gave me a good idea on how do we tell the, how are they acquiring images, and we look at the images. Can we tell them that, hey, what, you're taking images very far away from, the high resolution is there just because the drone cannot fly close to the pole, okay, because poles are electric, and also we don't want the drone to get entangled in in the wires, right? The equipment is very expensive, so they're going to be at at a distance. So by nature, the resolution of the image is very high, okay. So the range is 21 megabytes to 28 megabytes. That's one image. Okay. So now we have, we have the data. Now, why are we doing, why do we say we can do deep learning, and why is that even feasible? I'm going to reduce this. Okay. Yeah. So, going back to understanding how the brain really grasps the different shapes. Okay. So this experiment was done a long time ago by neuroscientist Hubel and Wiesel. And the thing was, they're studying the brain of a cat, and they're showing some simple figures like a line. And they can see that some parts of the neuron in the brain were getting activated. When they showed complex figures, some other parts. So it looked like, simple parts can be, inferred or deciphered by the early part of the brain, and as we, more deeper we go, we can, understand complex shapes. So this was, they both got a Nobel Prize for that work. So that is a starting point for, trying to mimic a human brain and developing something called a neural networks. Okay. A neural network is, okay, I give an input, how do I get an output? And we want to somehow, when we say neurons, all this terminology is coming from trying to mimic or understand how brain works. Okay. So we're actually teaching the machine, right? So that's why it's called machine learning. And when we say deep learning, so because deep is how many layers do you have? If you only have input layer and middle layer and output layer, that's not deep. It's just a neural network, all right? But if you have many layers in between the input and the output, then it becomes a deep learning network, okay? And when we say AI is, you want a machine to do some tasks. So it doesn't really matter whether we are, we are asking it to do tasks via machine learning ideas or deep learning ideas. So, AI is like, you're teaching something which doesn't know how to do, right? So, especially a machine. Okay. So there are different architectures, just like think about, different architectures for homes. So in deep learning, we can, one of the things that many, most of the energy and most of the time is spent on is images, So we need images for, it doesn't matter, right? For autonomous cars or autonomous tractors or, autonomous weed killers. So, so for dealing with images, we do something called a convolutional neural network. Okay. And when we are working with text, it is something else, right? It's called NLP, natural language processing. And for languages, we use something called, RNNs, right? Recurrent neural network. So, so for example, if you have a solids, if you're eating something solid, you use a knife, right? But if you're drinking something, you don't need a knife, for example, right? A liquid, the way you address liquid is different, the way you address a solid is different. So images, the way we process them, and we are going to build networks to do anything for the images, that is a different architecture and different concept. Whereas if we have textual data and if we want to understand, it doesn't really matter whether it is sentiment analysis or, we are doing the large language models like ChatGPT. That is about, text, and it is a different architecture and different, concept. So for images, the concept is, using convolutional neural networks, and our goal is to, it's whether there is a woodpecker hole or not. So this is a classification. So there are two things that can happen. Either there is a hole or there is no hole, right? So, so that's why we are using, because it's images, convolutional neural networks, and we are using, classification network. So this, the architecture that we are using is called BGG16. As I said, there could be different architectures. So the 16 is coming from the number of layers that we have between the input layer, which is going to be on the left-hand side, and the output layer, which is going to be on the right-hand side. Okay. Okay, so I'll just escape. I want to show you this. So the BGG stands for Visual Geometry Group. So this is a group that came up with this, architecture, which is from the Oxford University. So in fact, we are using, so I'll just go over how we are doing this. So let us assume that this is not the image that we collected, but I used an image from the internet. So this is free. You can, I can share this link. So you can go to their site, you can, put in any image you want, and you can, play with it. Annotation means we are identifying where the hole is in the pole. So if you think about it, there is a manual process. There is manual process in deep learning, in artificial intelligence. The ChatGPT was not done by machines completely, right? So there were humans which were feeding data to the machines, so there is, so the labeling of the data is very important. Does the data have a pole, right? Does the image have a pole? If it has a pole, does the pole have a hole, right? Ultimately, we want to identify the hole. So what we have done as one of the steps is to identify the images that have holes and draw a bounding box near the hole. Okay, so I hope you can see it. So let me. So all I did was, so these two already come default images that come with in the website. So I just have this download.jpg somewhere, and it is right now on my desktop. So I was able to, if you go here, project, you can add local files. Okay, so I added, I'll just show you again. So I'm adding, you can add any file that's on your computer. So this is the file I have. Okay. So we can use this, you can pick any, any shape you like. So I'm picking this. So I'm just going to make a bounding box. Okay, so that's called a bounding box. Okay. So what it does is it create, it is going to tell that there is an image. So, the image has a particular shape, right? You can see that, So you can see that, there are more pixels on this side, right? Rows than columns. Okay. So it already knows some properties of the images. So when we, put these boxes, of course, there are two, there are more holes, right? So I'll just put one more here. We can also be, we can be mindful and put a hole here. Okay. So once we
question in the chat, like they wanted to, if you could please share the link. That
yeah, we share it. Yeah, it's also in the, the PowerPoint. Yeah, the PowerPoint also has it. I'll show you. So
thank you.
once we do that, the annotation is very important. The reason I'm telling you is there was one student who worked at Tesla. Her job was to label data. If there is an image, does it have a stop sign? What does it have? What are the characteristics of that image, right? So she was paid very well, and then she took my some machine learning course at UC Berkeley Extension that I also teach, or I used to. So she just wanted to know whether she would be interested. And then when she realized that she does like it, what she did was she got a degree from Cornell Tech. So I also wrote a recommendation for her. But anyway, so this labeling is not a joke, because we might think that I'm putting a box. It's very important. Okay. And then what we can do is we can export this as a JSON file. Okay. So let me open it and I'll share this also. Hold on. Obviously, I think I have to choose it correctly, but it is talking about Swan. It is the Swan image information is also there. I should remove it, right? I should remove the Swan images. I really like Socrates. I don't want him to, I'm like, I don't want to see his thing. But then it also has, information about the download, download.jpg that, I named the images. So when you look here, the most important thing is, see, it talks about, we are looking for shape attributes. I made only what? I made 3, right? I made 3 bounding boxes. So we should have 3 shape attributes. So 1, you see this one? Okay. So the name of the shape that I used is a rectangle. It talks about, the X, the point where, so it talks about the origin of the bounding box. So it is happening at 98, 48. It has a width and the height. Okay. Likewise, there is another shape attribute because there are 3 bounding boxes, right? So it has another information. And then the last one is, this one. Okay. So what we want is, let me go back. So initially, we didn't have any annotations, right? So we have the original image. Now we have the same image, but we added annotations. So that where is that information located? The location of the bounding boxes information is a JSON file. So we can export in different formats. JSON is the best, okay? Because it's called. The idea is the origins of JSON format is that it is agnostic to. It doesn't need any prior application, right? So, for example, if you have an Excel file, you need to have Microsoft Excel. Right, but a JSON file you can open it without in any application. Here now I'm using Notepad++ or Notepad+, right? So the reason we want to identify that location is very important, right? So where are these holes happening? Okay, now going back. Okay. So we decided on this architecture. So if there is no, we don't have to be only picking one architecture. We can also try different ones. Anything that has classification, which determines whether there is a hole or not, right? So annotate the image. So draw bounding boxes around the woodpecker holes. So for this, we are using that particular, VGG. Actually, that group which came with the VGG 16 architecture also came up with this. This tool. It's a online tool, so we don't need to necessarily download anything. Just we have to upload our file to it, and then we can download the annotated file. We can also save that file, the annotated file also. Okay, now we can see that when we go back to the let me go back to the image, we can see that there is also there is pole. At least for this image, only 1/3 region is a pole. 2/3 is background or something that is not very important, right? Pertinent. However, so as I said, the resolution, for example, the size of the images were like 8,192 by 5,460. That is an image size. No, it's not. It's a big image, right? So it is very hard to process the whole image. We can't do it. It's going to be very expensive. So we have to, break this down, right? Break this image into sub-images. So what we realized is that what should be the size of sub-image? It should be 256 by 256. Okay, the width is 256, the height is 256. So that means that, if we have that 8192 by 5460, and, we are making images of size 256 by 256, we'll have 704 images, sub-images. So this one image will be we'll have. So now, what we have, then what we do is we use the location that we got from the JSON, okay, the bounding box information. And then we are like, okay, this sub-image has that bounding box. Okay, there is, obviously there is some code you have to write to, identify all that, but it's doable. And then what we are going to identify is that, oh, okay, these sub-images is all completely background. Sub-images with holes, hole with a hole, sub-images that only have holes, right? So we break the image, we'll, into sub-images, and we can, unfortunately, based on the annotations, based on the locations, we can actually, it's easy to identify the pole with hole. Okay, and we can put them aside. Now, coming to the other sub-images, right, which could have pole or the background, we have to make sure that we have equal proportion, right? We don't want to just have, too many background and only fewer images with pole with hole. So, the balancing, having equal proportion is very important for a good model, okay? Otherwise the model will be, it will be either a poor fit, an underfit, or an overfit based on our training data, right? So, how much data we have and what are the proportions of different groups is important, right? So since, our end goal is to identify hole in a pole, so we are going to, any model, it's going to only consider numbers. So we can have, if you look at image is nothing but numbers, right? So pixel intensities are integers, okay? But which image has a hole and which image doesn't have a hole is also important, right? That's where that target is, which is a label, right? So it is categorical. So we can say, yes, it has a hole, no, it doesn't have a hole. But when we have to convert that into numeric before we feed it to the system, right? We feed it to our model. Because just like computers, regardless of how the PowerPoint is, when I store it, it is in ones and zeros, right? So it's in binary format. So just like that, any model, regardless of machine learning or deep learning, all the models are going to, the data you're feeding, everything has to be, even categorical data has to be converted into numeric. Okay. So, so we have the image the sub-image will be an array. Okay. You can make it into one-dimensional array, right? A two-dimensional, 2 by 256 by 256 can be, flattened using, there are a lot of flattening methods in NumPy. And, we can have that, comma, the corresponding label. The label could be 1 or 0, right? So we create the data, okay? And then, so make sure that, we have equal number of data with ones and zeros. So that is, that is how we would prepare the data, right? Preprocessing is get the data, and annotate it, and based on the JSON, automatically pole with hole will be, we can put it in a different folder. Pole and background can be put in a different folder, but I think there is some kind of manual involvement still required to make sure that, because if you think about it, if you go back to this image, we can see that, even the regions with pole, we have to be mindful where they are, right, in the sub-image, because There are going to be sub-images with nothing, only just background, you know. And another part is that here, you know, the image, the pole looks very clear, but it also depends upon the date and time, right? Day and time when it was collected, the image was collected, and also the background. Sometimes the background could be like, you know, it will be, the drone is here, the pole is here. So you might be looking down and, you know, we could have fields that are in green color, brown color, you know, there could be water. So sometimes the pole is bright, you know, the pixels are brighter, not brighter and all that. So there are a lot of things that can happen, and a lot of possibilities. So we want to, you know, we want to have different poles with whole different images, right? So sub images. We don't want just everything that looks bright. We don't want everything that looks dark. We want to have, you know, mixture of possibilities where we can still identify. Identifying is important, and for that, you know, so maybe sometimes we have to zoom in and all that when we are annotating. So the challenges are that, you know, for computational challenges are large data set. So each image is, you know, as I said, it's between 21 to 28 megabits, bytes. And, you know, as I said, you know, if I really look at the pixel, in terms of pixels, they're 8192 by 5460, you know, average. So, so chopping that image into sub images is expensive. It's not cheap. But, you know, we are using cloud computing. So all the pre-processing is done on the, you know, physical laptop. So training takes long compute time. So for training and, you know, testing and all that, we are using cloud computing. Okay. And these are the lot of references, you know, that I used, and yeah, that's about it. So we are almost done with the project. So we are going to present to the partner soon. So whatever presentation, you know, this course is known as a capstone projects, or, you know, yeah, capstone project. So the students are also expected to present to everybody on campus. So they do a campus presentation and we are also going to do a special presentation to the vendor. Okay, or the partner. Okay, that's about it. You know, thank you, Sravasti and Women and Big Data for giving this opportunity.
Thank you, Sridevi, for sharing your knowledge with us, as well as the use cases, because theoretical knowledge we can have, right? But seeing the use case implementation for real-time scenarios in the industry, that's very awesome. So thank you for sharing that. Does anyone have any questions? I didn't see any questions in the chat. So I had a question. Maybe I can quickly put one slide and then ask. So I think you were mentioning, right, that there are, like, you use 16 layers, right, for the neural network, right? So how do we ensure that, you know, for each of the 16 layers, right, like the second, you know, is much more deeper understanding than the first one? So how do we ensure that when
yeah, so that's a good question. Going back to that, you know, the cat experiment that Hubel and Wieser did. So the first few layers are going to help us capture simple figures, simple forms. Okay, as we go deeper and deeper, we are going to understand complex forms, right? So here, one thing to remember is that, you know, our image is 256 by 256. It's not 224 by 224. But by 3, that is about a color image. So when we look at a black and white, it's a 2-dimensional. Okay, so black and white is like a, you know, this sheet of paper. Okay, but a color image is, it has, you know, 3 channels. So there are different protocols, right? You know, you can have color image in different protocols. So you can think about each color image has 3 channels. Okay, so when we see an image, it's an average of all 3. But we can also see, in different channels in each channel. So the channels that we are using are called as RGB, that is a format. Okay. So the
Yeah.
3 is coming from that. Okay. I mean that we are using 3 convolution filters. So that is another thing, right? So you have an image, it is 3, it could have, it could be a color image or a grayscale image, regardless. So the 3 is the first filter that we are, it's not one filter, there are 3 filters. Okay. So each pixel, so depending on your filter, or our filter, no. Okay. So this is the image, okay? This is the filter. This is the filter, okay? So 3 such filters are applied to each image.
Okay.
Or in this case, each sub-image. Okay, so that's the first one. So then what we are doing is, so while we look at everything, right, when we look at the whole, that image that we looked at, we can see that there is an image, but then there is a pole only at specific location, right? So that means that the whole image is not important, right? So what we are doing our sub-image. So what we are doing is after the convolutional layer, which has 3 filters, what we are going to do is, hey, we are only going to look at pixels that are significant. So when we say significant, higher value, right? In a neighborhood, in a given neighborhood, again, we say, do we want to look at 4x4 or, 8x8, whatever. We are like in that 4x4, what is the highest value? We retain that highest value. Okay. And then we go to next step, which is here we are saying that we are going to apply a filter which has 128. So it's a 128 filters. So you can say that, the image, we started off with 224 by 224 and then max pooling. So it has 3 filters at the first blue, right? The next one, max pooling is happening. Okay. The filters are 64.
Right.
Okay. The next convolutional layer, 224 divided by 2 is 212 or 112, right? Okay. So max pooling is decreasing the size. Okay. And max pooling, what it is doing is we are applying 128 filters. Okay. Then after that second convolution, again max pooling. Okay, decrease the size. So basically what we are saying is that there is a huge image. Only every single time we are only picking up significant pixels. So that's why there is a shrinkage in the size of the image. Okay. And so this is another max pooling. At this point, we are using the 256 filters. Again, convolution, so now 112 divided by 2 is 56, right? Okay, and 56 and 256. So this is a continuous series of processes. 1 second, Sana. So what happens is, the ultimately, the output, so regardless of the image, the output is whether, the label is 1 or 0, right? We're looking at binary classification. So after a bunch of, making the image smaller, at some point, still the image is there, we have to flatten it. That's where these fully connected layers are coming. Okay. And flattening is happening, and the max, softmax means that we are using a function which is going to give us probability. This image, it has, probability of 0, not having hole is high, having a hole is low. So for each image, it's going to give us a probability, whether, it will give us, the probability when we add them up, for 0 and 1, it should be 100%, right? 1. So, but the softmax function is the one which is going to help us determine whether the image, has a hole or it has a no hole. Yeah. Sana, you had a question.
Yeah, thank you for sharing. So Modupe has a question. Can we have an idea how large the data sets were?
Yeah, so the data set, each image was around 21 to 25 megabytes. That's one image. And the sub-image size is 256 by 256. So in terms of pixels, this can correspond to, if I can find the insert approximately. You can think about it. This is one of the images size is this. Okay. So when we do a sub-image size is 256 by 256. Okay. So for this particular size, they won't be exactly 8192 by 5460. So there could be some variations, but when we divide, when we create sub-images, for this particular one, we got 740 sub-images.
Great. Thank you for sharing that. Lawrence also has another question. Did you do supervised learning to create the model, or did you leverage an existing model and feed the images into the visual model?
So this is a supervised learning because the target is, so we know the target. A good question. So we haven't, yeah. So we haven't used the training weights from another data sets yet. So that is a good idea. So we have to do. Thanks for reminding me. Okay. Yeah.
Great. And I was monitoring, so there were no further questions. Everyone is saying thank you. So
Yeah.
nice project. Troy
Thank
also
you.
said everyone is thanking you.
Yeah, thank you guys. It was really nice, giving the present. Thank you, Bala. Yeah, thank you, everyone. Bye.
Excellent. Great. And we're running out of
To
time.
everyone.
Yeah, 4 minutes over. Okay. Thank you so much. Great presentation.
Yeah, thank you for sharing your knowledge with us. We appreciate this.
Yeah, thank you.
And for the rest of everyone, for the data camp learners, please continue learning. And even I'm doing the same. When I was job searching, at earlier point of time, I never got this kind of opportunity for data camp with a free license to be able to do free certification. So really encourage you all to take advantage of it and get certified.
Oh,
Thank
I
you.
want to share something. Hold on 1 second. If anybody's there. So one of the persons, who was in the group that I mentored in fall, or spring last year was Eliza. So she's a doctor, but she joined the mentee group of women in big data. So they were in that group. There was two software engineers. There was a lawyer. There was a medical doctor. She actually she's extremely she's smart. She joined, Georgia Tech University, and she's getting a master's in interactive intelligence. Okay.
Wow.
So these, I think that what Women in Big Data is doing is good because, instead of when we are trying to learn, we feel like it is a, soul journey, right? You're all alone and there is nobody. But I think this is giving an opportunity for you to interact with others from different fields. So you should not feel like, hey, I'm alone and I'm learning, but there is a support system here. Yeah. That's it.
Yeah. Thank you for sharing that, Shri. Yeah, Eliza is very smart. I remember interacting with her, and from the last I've always heard you talking good things about her. Thank you, everyone. Then we'll close the session out and we'll stop recording then. If you have any questions, please feel free to stay back and ask any questions.